Hello, welcome to the large dataset exam briefing. My name is Tony Devlin and my objective is to re-familiarise you with the key data in the large dataset in preparation for your examination. Now, there's definitely some advantages in that the examiners will assume that you know and understand the large dataset. In particular, they can assume that you're familiar with the terminology and the context of the data. So we're going to move straight on to discuss those. The large dataset includes weather information for 5 UK locations: Camborne, Herne, Heathrow, Leeming and Lucas, and 3 further locations: Jacksonville, Beijing and Perth. The information is collected only from May to October. It's important to remember this. Things that you should remember are factors that might affect the weather in these locations, in particular how north or south is the particular location. If you look at the locations in the UK, they're almost alphabetical from south to north, except for Heathrow and Herne, which would be around the other way. So take note of which are coastal, which are inland, and the ones that are coastal are also more likely to be the windy ones. Looking at the world map, we'll put on the equator, and we'll see that Perth and Jacksonville, Florida are about 30 degrees north of the equator and 30 degrees south of the equator. The UK is at a latitude of 50 degrees north and Beijing is at 39 degrees north. Okay, let's take a look at temperature. Here are box plots of the temperatures in the large dataset, showing you the temperature range from May to October. Notice that Perth seems to have a low temperature, but that's because it's winter in the southern hemisphere. So comparing Perth with Jacksonville wouldn't be fair at this point in time. Finally, it's important to know that the dataset has a number of gaps. These are marked NA, which means data is not available, a particular data measurement for a particular day. And you'd need to exclude any values with NA from the analysis that you're asked to do. Also notice that there's quite a lot of outliers, particularly in the worldwide locations for temperature. Moving on to pressure. The pressure is measured in hectopascals, which means 100 pascals. It's the same as a millibar. And we can see, again, the pressures from May to October. Perhaps the most notable one is Jacksonville, which has got the smallest interquartile range. The average pressure at sea level is 1,013 hectopascals. And you'll notice that there are a lot of outliers, particularly in the UK. If we look at rainfall, that's measured in millimetres. Again, this is May to October. So if you were comparing Perth on the right hand side with the other locations, you'll see that it's getting more rain than everywhere else. But it's winter in Perth and it's summer in the other locations. Also, you'll see that this is not a terribly useful graph, as most of the data is outliers. That's because the majority of data items will be very low levels of rainfall recorded in a particular day. Many items in the dataset have got TR written as the rainfall reading. This means traced, and this is used when there's less than 0.05 millimetres measured during that day. If you're asked to do a calculation during the examination, you need to include these items and set them to 0 in your calculations. Notice that they make a particular difference if you are calculating the mean or the median, for instance. Okay, here's a picture of the monthly rainfall. These are trended from May to October, and you can compare the 2 years, 1987 and 2015. If you notice the green peaks on the upper graph, these are all indicators of the Great Storm in the UK in October 1987. That's why you get a significantly higher level of rainfall in these months, and the amount of rainfall was higher in the south than it was in the north. Moving on to wind speed. Wind speed is measured in knots. 1 knot is at 1 nautical mile per hour, and you need to know that 1 knot is equal to 1.15 miles per hour. You need this. Sometimes they ask you to convert between the two units and don't give you the exchange rate. In addition, wind speed may be measured on what's called the Beaufort scale, which is a numerical scale with discrete values from 0 to 12, depending on the speed of the wind. This data set particularly has got a lot of gaps in, and NA means not available, so you exclude those values from any analysis that you're asked to do. Maximum gust wind speed, so this is the biggest wind speed measured during the day. Again, that will be measured in knots, and 1 knot will still be 1.15 miles per hour. Looking at wind direction, on the right hand side of the screen you'll be able to see a table showing the cardinal direction, that's the compass direction, for the 5 UK locations, and you can see the number of days that are recorded with the maximum wind direction being in north, north, east and so on. This again will be a discrete variable, the cardinal direction, and it's shown in a radar chart in the centre. And the radar chart, if you look at the darker blue outline, that's for Camborne, you'll see that has got prevailing winds which are west and west-southwesterly facing. And if you look at Leeming, which is the gold coloured, you can see that that has a south-southeasterly direction, a westerly direction and a northerly direction as 3 particular directions where the wind is measured. Okay, move on to cloud cover. That's measured in octas. An octa tells us how many eighths of the sky are covered. Octa again is a discrete variable. It can take the value 0, 1, 2, 3, 4, 5, 6, 7, 8 for the number of eighths covered. And also you'll notice from this chart that there's a negative skew. It's not a uniform distribution. It's got a negative skew, meaning that the thin tail of the frequency distribution points off in the negative direction. And that also means that it's more likely to be at the cloudier end of the scale than the clear end. So, to give a summary of the variables contained, I'm going to talk through a table which correlates the variables against one another. So here I've taken a random sample of 100 days of data from UK locations, and I've done the correlation of each variable against every other one. Firstly, looking at the critical values for the correlation, you can see there's a size of 100 is the sample, and so the critical values are relatively low for the correlation coefficient. So a correlation coefficient of 0.2565 is enough to support a significance level of 0.05 that actually the variables are correlated. So let's take it one variable at a time. Temperature, reminder again, measured in degrees centigrade. We can see that that correlates positively with sunshine. No surprise there. Rainfall, measured in millimetres, is negatively correlated with pressure. So higher rainfall when you have lower pressure is negatively correlated with sunshine. Pressure, hectopascals, so that's 100 pascals, so 100 newtons of force per square metre is the pressure. And we can see that that's negatively correlated with wind speed, so higher pressure, less wind, and vice versa. We can see it's positively correlated with sunshine and negatively correlated with the maximum gust of the wind. It's also negatively correlated with cloud cover, so higher pressure, less cloud. Wind speed measured in knots, remember that they're 1.15 miles per hour. And you can see particularly the wind speed, not surprisingly, is very strongly correlated with the maximum gust speed. It's negatively correlated with the relative humidity, and it's also positively correlated with visibility. Sunshine in hours, that's negatively correlated with the relative humidity, very negatively correlated with cloud cover. Too much cloud, you're not going to get much sunshine. And it's also positively correlated with sunny. You can see further on a sunny day. The maximum gust, measured in knots, negatively correlated with relative humidity. Relative humidity is the percentage of how saturated air is with water vapour. If it's 95% plus, then that tends to relate to mist or fog. So here you can see that it's positively correlated with cloud cover, which you'd expect, and negatively correlated with visibility, which you'd also expect. Cloud cover, measured in octaves, how many eighths of the sky is covered, and that's negatively correlated with visibility. And then finally, visibility is measured in decameters, that's tens of meters, so that's how far you can see. Okay, that's all folks, hope you found it useful.